In the next couple examples, you're asked to help somebody determine whether or what shape they have created in real life and using coordinates. So we want to see how we would check for these characteristics in real life or in coordinates. So in real life, for theorem 6.17, if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. How would I check to see if something's perpendicular in real life? Well, of course, I could use a protractor. Protractor, I could measure the angle and see if it's 90 degrees. If I don't have a protractor, I could use an old builder's trick, which is called the 3-4-5 triangle. So if I was building, let's say, a frame for a deck or a wall, I could measure 3 inches on one side, 4 inches on another side. So I could measure 3 inches on this side, 4 inches down here. And then if I measure between my marks, if this was a 3 and this was a 4, I would be checking for what we call a Pythagorean triple. The hypotenuse should be 5. So I would use a tape measure and look for a Pythagorean triple. The Pythagorean triple is just 3 numbers that work in the formula a squared plus b squared equals c squared. If I was using coordinates and I wanted to check for 90-degree angles, I would look at the slopes of the lines. So if I wanted to check for 90 degrees, I could use the slopes. And what I would look for is that I had opposite reciprocals. And an opposite reciprocal, an example of that would be like 1/2 and negative 2/1. One of them's positive, one of them's negative, and they're the reverse. 1/2 and then 2/1 is the reciprocal. In 6.18, one diagonal of a parallelogram bisects a pair of opposite angles, and then the parallelogram is a rhombus. The only way I could check for that in real life is to use a protractor. So I'd be looking for congruent angles. So protractor again. And what I'd be looking for here would be congruent angles. So I've just used a protractor, or if I was building something, I'd probably have a speed square with me. And I would just double check, for example, 5 and 6 should be the same measure, and 1 and 2 should have the same angle measure. There's no real way to check for this using coordinates. So I don't have a way to check for that using coordinate system. Theorem 6.19 says if one pair of consecutive sides of a parallelogram are congruent, the parallelogram is a rhombus. So first of all, in this one, you first of all have to establish that you have a parallelogram. And there are many things you could check. Opposite sides congruent, opposite sides parallel. Your consecutive angles are supplementary. Your opposite angles are congruent. And you could check to see if your diagonals bisect each other. But here, once you've established that you have a parallelogram, all you need to check is that 2 consecutive sides, in other words, 2 sides that are touching, have the same length. Well, in real life, if I want to check length, I use a tape measure. And what I'm looking for here are congruent lengths. If I'm using coordinates, what you have to look for are congruent lengths, and to do that, use the distance formula. And again, I'm going to be looking for congruent lengths, but I'm going to be checking to make sure, in the case of here, in this example, AB should be equal to BC. Now remember, the distance formula is based on Pythagorean theorem. It is the square root of a squared plus b squared, where a and b are the horizontal and vertical changes between the two coordinates.